You guys all sort of at the end of the TAing or teaching or whatever, or is there stuff going on into the spring and summer? You're all finished, aren't you, Malors? Oh, we got to grade the final, yes. Multiple choice? Did you make it multiple choice? I don't know if you're allowed to do that. I don't know. Oh, you are? Oh. Of course, it takes almost as long to make up a multiple choice quiz if it's a good one as it does to grade a regular one. Yeah.
I get very emotional grading.
Do you? Because you feel they haven't paid attention to your lectures and they haven't taken the trouble to learn what you said? Yes, I guess that's sometimes it's not too hard to take that personally.
Was scaring the students. They say you are going to take that final.
Pardon me?
Like some of your students in the presentation told me they're going to have a takeout final.
Yeah, it's a two-day take-home final.
I told them to do very hard tests.
I don't think I do, really.
I never taken any of your tests.
Oh, okay. You just were giving them a hard time. I think I make them too easy, but they're big people, you know. Mostly I care about what they learn, but we'll see. But what did they say, Waleed? Is there some?
The person said it should be working, even if the screen is not on.
Oh, is that so? Okay. All right. So as I said last Friday and this morning, I've got an awfully long way to go to understand what I'm proposing here. The idea is to try to get an explicit automorphic form of a very, I think, fundamental object in geometry, arithmetic geometry, the exponential mixed motivic Galois group that seems to have fundamental role in physics and maybe lots of other places, and it's a generalization of the motivic Galois group. I gave a conjectural explicit construction about a month ago of the automorphic Galois group, and the goal would be to get an equally explicit construction of the exponential mixed motivic Galois group. But it's tough because we're talking about much bigger theory. So how should I begin? I'm going to make, it's beautiful. It just looks beautiful, all of the stuff that's going into this, but nobody seems to really understand it all. So let me see. I'm going to do a series of comments. The comments is not quite the right word. Series of, it's a conversation. I mean, of different little, it's an extended description of how perhaps I and maybe others might think of it. So what we have, and that's what I talked about this morning, among other things, what I reviewed was we have, this is the automorphic Galois group. We hope we have this. This is the one that was related to the Bailenson conjectures, or really it was the motivic version of that. So strictly speaking, this is really what we have a conjectural definition for, as well as the arrow here. And this is this is the one that would be related to the Bailenson conjectures that we talked about. But now here's the much bigger one. I'm putting a tilde on it to mean exponential motivic group. And so that's what we want. We want these things. Oh no, I'm sorry. We have these things as a conjectural definition, and then something along those lines. This is what we want. So I'll put that under. So we talked about that this morning. What we want an explicit construction, of course conjectural, explicit construction or conjectural construction of this thing. This is supposed to map down there, of the right hand vertical arrow. i.e. of the group I'm writing it as GF plus. Plus means mixed, not just ordinary, and tilde means exponential, as it's an extension of the group without the tilde on it. So this is the group studied. This is kind of the main thing you could imagine, studied in FJ, Jossen and Frezan and Jossen. This is the 296-page preprint online that's going to be a book. And it's, for the most part, quite nicely written. It's just too full of stuff. But I mean, you can tell that the stuff is beautiful. So it seems, but anyway, that's what we want. And we want it in terms, as this diagram suggests, in terms, in automorphic terms. It's not really going to be explicit unless you can tie it, it seems to me, with automorphic representations. They're much more concrete. And so this is in automorphic terms, studied in. So comma, in automorphic terms, in the role or in the form, the group, L, F plus, this thing. So this is what's discussed in this thing, albeit in rather in many different ways, and most of which I don't really understand, but I would love to understand them. This is what we want. This would be in more concrete automorphic terms, a description of that. The suggestion, so I guess what I'm suggesting, or hope, let's say, the group, this thing we're looking for, LF plus tilde, will ultimately be defined explicitly in terms of something that's rather new, something that has not been a part of automorphic representation theory, although it has been studied reasonably extensively by a group of mathematicians. I mentioned this on Friday too, in terms of topological extensions. Just using the ordinary topology and talking about central extensions. The adelic group GA here has a topology on it, and we can, of course, be talking about extensions of G in the algebraic group sense, but beyond that, these locally compact groups have extensions which are not algebraic and which exist even if this algebraic group is simply connected. So in terms of topological extensions, I forgot to write that down, topological extensions G tilde of GA. That's our hope. So these are, maybe I'll put double bars under each of these little things that we're hoping for, or sort of sections of this discussion. And so here's another one. These extensions, okay, so this is a further description of these hoped for extensions. These extensions, forget about the role that we're hoping for in exponential motives. These things are a purely automorphic thing, a purely representation theoretic thing, and that's the way people are thinking of them these days. They're destined to become a major theory. Whose development, I think it's fair to say, even though a lot of effort has been put on them, it's mostly just on the group theoretic side of things. Forget about the analysis. Whose, that I guess is going to come later, but whose development is just beginning. And I should say it's just beginning, let's say, with the work. I've mentioned this before, but with the work of Weissman, two S's, I guess. He's the person that's been thinking about the structural side of this on BD. I'll write that for Berlinski, Deligne extensions. So the development is just the beginning with the Weissman, with the work of Weissman on BD extensions. In this paper that I mentioned before, but I'll mention it again, G, this is Wietek Gan, and Fan Gao. On what do they call the Langlands? Weissman program. Okay, so that's also a nice, I think they have something else, yes, and BD extensions. So that's a pretty lengthy paper, and parts of it are quite clear, are quite transparent. There are some parts of it that I didn't, some K-theory, these things are parameterized. I say right at the beginning that these extensions, according to these particular, they may not even be all of them, but the Berlinski-Deligne extensions are the most systematic theory of such extensions, and they're parameterized by a certain K group, a K2 group, in a particularly difficult, or at least in the context that I don't know about. But it's, I'm sure, easier to learn, or can be, one can learn it. I'll leave I'll leave this here just for the moment, since I've written too low on the board. And I will say, as a first step, and I think I may have said this before, as a first step, well, it's a shame to call this a first step because it's really quite an achievement. It's a maybe 200-page paper, 250-page paper that is really very systematically succeeds on something beyond just the structure of these extensions. It really succeeds in the analysis, the harmonic analysis of these extensions. Well, not of all these extensions by any means, only a small collection of them, but the ones that have been most studied, and it's called the stabilization. And he writes well too, even though this is a difficult subject. Stabilization of the trace formula. This is what's going to be needed to study the representation, the general representation of these extensions. So stabilization of the trace formula, can't read my own writing, for metaplectic groups. Okay, so metaplectic groups are the things, they're the BD extensions, a very small collection of them in the general scheme of things, but they are the ones that occur in the theta correspondence. I, in fact, left out something I perhaps wanted to say on this. Among other things, so I'll just say, what's this theory going to ultimately include? And I'm not even talking about its possible relationship to exponential motives. I'm just talking about it as a branch of representation theory in automorphic forms. So the sentence is, these things are, whose development is just beginning. And so this is concluding the sentence over there. Among other things, it would include, okay, so if we had a good theory of that, it would include L functions. We don't quite know, they do talk about L functions in GG, but we don't really know whether they're the same as automorphic L functions or whether they are equal to them. But in any case, we would want a theory of L functions, trace formula in general. Beyond endoscopy, L functions, trace formula, stabilization. It's trace formula and it's stabilization that's handled here for metaplectic groups. And then endoscopy. And then I guess we usually write BE for beyond endoscopy. So those are the kind of things that one would like to have in this, I mean, we don't have this really much at all. And actually a good chunk of this, we don't even have that in the regular automorphic version. So, but anyway, we can expect, and we would like ultimately, these things for these topological covering groups. Okay, and there's something else. So there's one other paper. It's not really a paper. Let's call it DW. And so this is interesting. This is letters. It's easy to blog. It's letters between Deligne and Weissman. So it's easy to call this up on the internet. They start at, I think it has a heading December 14th, 2007, but they go on for 10 years. There's a whole bunch of them. It's about 40 pages, and it's very instructive. Deligne is a little bit rude sometimes in his letters with Weissman, but that's just the way he is. He's blunt if he doesn't like something. But it seems like a very lively and interesting correspondence between the two of them. Parts, it's hard. There are things in here that I don't really fully follow, but they're worth studying. And I should also say, this is where, right at the beginning, this is the quote of Deligne. Right at the beginning, he says here that automorphic representations, let's say automorphic representations of groups G tilde A of these topological covering groups will be as important. I think he actually says more important. They will be as important for the new information that they they provide on automorphic representations, classical automorphic representations of GA. So there, he says he is in his opinion. So he's saying that that's just his feeling, that they're at least as important for the new information they provide about automorphic representations, as well as in their own right, as well as what they give for these groups. Okay, so that's what we can say about these BD extensions. On the other hand, okay, so this is an extended conversation. These extensions are the first little paragraph. The next paragraph is on the other. It'll be an on the other hand paragraph. Okay, so on the other hand, exponential motives. Are already. So I'm claiming that these things, the theory, the automorphic theory, in quotation marks, of these groups G tilde of A, is at a cruder stage. It's really just beginning. The exponential motives theory, are already a major theory. As described in, so anyway, I have written this down and referred to it many times. Fressan and Yosen, exponential motives. So this is a 200, this is the thing I just mentioned not a few minutes ago. This is the thing, this is a preprint on the web that's, I think, quite clear, and for the most part, and when it's not clear, it's because they're just appealing to advanced theories, advanced techniques from arithmetic geometry and so on. But it's called exponential motives, and another one, which I think I may have mentioned. Let's call this GA, Greg Anderson. Cyclotomy, I don't know, cyclotomy, perhaps, and an extension of the Tanyama group. Okay, so that is, where do we have these things? That's up here. Oh, I didn't, it's not in my diagram up there. But this, the Tanyama group maps the Tanyama group. That's actually a short exact sequence. And here, there is an extension of it. And these are short exact sequences. I won't put the ones and the ones down there. But this is the thing that was discovered by Anderson in the process of solving a very explicit and concrete problem having to do with very traditional things. Fermat surfaces, I guess that's what they're called, Fermat surfaces, the motives attached to them, and how the motives attached to them have little smaller pieces, or let's say they break into what turn out to be exponential motives. And since they have to do with motives of CM type rather than general ones, that is to say motives that in some sense are attached to tori, these and this, those are basically for CM motives, and so these would be CM motives. These would be CM exponential motives. He wrote down the group that would replace this. It's a covering of this group, an algebraic group defined over Q, and I think it's an extraordinary paper. I think it's got to be, can't say to understand all of it, but it's well written, it's brisk, he doesn't waste any time, and it's got to be one of the great papers, well, I exaggerate a bit, but one of the great papers in number theory of the last 50 years. This is 1986. And it has, for a great paper, it has all of 7 citations in MathSciNet. So what can one say? But anyway, these guys refer to it. They incorporate it to some extent in what they do, and it's an important paper. And so I'll say then, despite this, despite the fact that this theory is really quite well advanced in especially F and J, no one seems to have suggested relating this extension of automorphic theory, that is to say, GG and what was discussed in the letters between Deligne and Weissman, so relating this to this. So, lots of people have been, how should I say? I'll say, that doesn't seem, I mean, is this a bad sign? I mean, I don't know, actually. And Deligne has actually worked in both of these things, so that's maybe a sign of caution. Caution for me anyway. Yes. No. This is done. This is done. These guys. This is much more recent than this. This is, I think it's dated. The preprint is dated 2014. And they discuss the role that this plays in this near the end. No, I'm talking about relating these guys to those guys. These guys to these guys. As far as I know, no one has suggested that, and that is, I think, for me anyway, it's a sign to be cautious, because you would think that Deligne, if it's so obvious, or Deligne would have noticed it. So, in any case, sign for caution. All right. Well, so these are paragraphs. The next paragraph is the word, I put in the word well, as if it's a conversation. There is some evidence. So there is some evidence of ties between the two. So what I'm talking about is, as the question you asked, on the one hand, this. So between Fj plus Ga on the one hand, and Gg. What else? Do we just have one reference for that? Oh no. Wenwei Li, and maybe let's throw in the letters of Deligne, Weissman that's kind of like the automorphic extension. Okay, so there is some evidence for ties between these two, and it includes, I'll write down what is evidence as far as I can see. Okay, I'm not going to discuss these things in any detail or explain why it's evidence, but it I think is evidence. We'll put this up here. Okay, so including one, the Shimura correspondence. What's known as the Shimura correspondence for modular forms of half integral weight. This is from 1973, goes back a long way. Two, and I looked at this. I confess I haven't read Waltzberger's paper that I'm about to mention. Waltzberger's construction or study of the Shimura correspondence. In terms of the Shimura correspondence, in terms of what's known as the theta correspondence. So I'm not just saying why these represent evidence. I'm not really in a position to do so. I'm going to work on these things hard in the next little while. So these would be, there are two papers, 1980, 1991. And for both of these, just the beginnings of it, see, so there's not one would have to follow the leads that are in this, but see Wikipedia. Wikipedia for these last two. So I'm just saying I believe that they relate, but I may be wrong on this, but I believe what they do. So this is a parenthesis on these two bits of evidence. I believe they relate automorphic L functions for certain groups. This may be, I didn't investigate this, but it looks like they certainly relate the data, the families C, remember the data, the C or the families of semi-simple conjugacy classes in the dual group. They do relate, but I think they relate automorphic L functions for certain groups, very particular groups in terms of L functions, traditional automorphic L functions. Not a tilde. Anyway, it's very well worth. I intend to look into this in the next while. The main theorem, I already mentioned this. The main theorem in Greg Anderson's paper, which on the one hand defines an extension of the Tanyama group, and this, but what it is it's a factorization of motives, traditional motives, for Fermat hypersurfaces. Into what he calls, into it's a factorization of these things, the motives for Fermat hypersurfaces into exponential motives. That's what we're looking for. In a very particular case, he calls them ulterior. I don't even know if the term exponential motives were invented at that time. He calls them ulterior motives. He doesn't make jokes about this, but I guess that's sort of a play on words. And also as I said, this is taken up in Froissart Yosen. It's actually section 13.1. So I consider that to be evidence in favor of what we're proposing here. I suspect a systematic examination of Wenwei Li's paper will yield evidence, but I don't know for sure. A systematic study in Wenwei Li of metaplectic groups, very broader class of extensions, but really just where he's increased the rank of the group. It's not just SL2, but increased rank, but still very small extension, topological extensions. That's what metaplectic groups are. They're extensions of the symplectic group, as opposed topological extensions of the symplectic group of arbitrary rank, as opposed to just the special case of SL2. And then finally, I'll say, gosh, do you mind if I go a few minutes over? Is that okay? You feel free to, if you have commitments. I'll just go a little bit over. Similarities. So similarities, if one looks in GG, there you see that there are similarities in the construction. I mean, I haven't checked it, but it looks like there are similarities in the construction of L groups. These letters of Deligne, between Deligne and Weissman, and then the work of Weissman that went into most of that, constituted most of the paper GG, it's just about defining the L groups, that local and global L, or even just mostly local, the construction of L groups, G, L tilde, and GL. So it turns out there appear to be similarities into this construction. This is in GG. And the factors, let's say perhaps, since I need to check it more carefully, the factors GC, so perhaps the factors GC, this one hasn't been defined yet. This is what we're proposing, but these are automorphic things. These are things that would go into the, this one hasn't been defined, but this one has. of LC tilde. This is what we hope to define. And the factors, if we try to copy the factors that went into LF, I'm sorry, the factors G tilde C and GC that I think I perhaps should be calling these LC. I don't know whether to call them LC. GC would be the factors for the motivic part of it. I think the way that I phrased the sentence, I'd better write this as LC and LC tilde and LC of these automorphic. This would be the putative automorphic, putative exponential automorphic Galois group, a locally compact group, and this is the one that we've already described. Beyond that, I have just a philosophy that I'm going to read out because I'm not going to write it down. There's really too much to do here, but philosophical support. So this is an extended conversation, and there's evidence that those things, to my mind, constitute evidence for the ties between the two. And then just general philosophical support. Do you want me to write this down, or shall I just say it? I'll say it. Many automorphic representations pi of groups GA conjecturally I'm going to write it down. So many automorphic representations so many automorphic representations pi of just traditional groups of groups GA conjecturally characterize motives. Ordinary motives. It's the general version of the Shimura-Tanyama-Vey conjecture that every motive should have an automorphic meaning, and it's given by the homomorphism of the group LF into the group GF. Any automorphic representations pi of groups GA conjecturally characterize motives. And it depends on your philosophy, but this is their role in life, many people would say. The role of such automorphic representations is to characterize motives, which are fundamental arithmetic things. Let's say this is their role in life. This is their mission in life. That's some people would dispute that, but anyway, that's the role in life. The automorphic, on the other hand, the automorphic representations, and I'm putting this in quotation marks, of this larger theory, the automorphic representations of groups G tilde of A outnumber the automorphic representations pi? If so, yeah, they ought to outnumber these automorphic representations pi, but Deligne's opinion I don't know whether this is constitutes in your mind evidence, but Deligne's opinion, so they outnumber those, but Deligne's opinion is that their primary role, that their role, these ones that outnumber them, that their main role is to give finer information on the representations. Fine. Well, if he's right in this, if so, if this is so, and if these things, the ordinary automorphic representations, many of which characterize motives, if the broader class of them characterize, if their role is to give finer information about these, if this is so, shouldn't they this is not a strict logical inference, but just trying to think freely, shouldn't they also characterize serious extensions, serious generalizations, let's say, of classical motives, M. Shouldn't they characterize, let's say, a serious generalization of classical motives M? What is it? Well, we've already got it. There's only one thing it could be. Exponential motives would seem to be the only candidate. So what is it? Question mark. Exponential motives. Would seem to be the only candidate. You could also work through philosophically in the other direction. You know, you've got classical motives, you've got exponential motives. In some ways, exponential motives are built on classical motives. Shouldn't the things that characterize classical motives then be built upon a broader theory that is kind of parallel to exponential motives versus ordinary motives? I won't write that down. You know, I've got another 10 minutes or so. What do you want me to do? Shall I maybe do this on another occasion, or should I spend? I mean, I'm putting you on the spot. Okay, I'm going to spend 10 minutes, 15 minutes on a final paragraph to this conversation. And so let's call it a program, what we should be doing. So feel free, I'm not going to mind at all if you have other commitments and have to leave. But here's the program. Try to guess at an explicit formula for, well, I guess for what would be an automorphic analog. I'm going to write it both of L tilde and a mixed plus in the spirit. So this would be the group that ought to be the automorphic analog of the exponential mixed motivic Galois group. And I'm saying just try to guess an explicit formula for this in the spirit of what we have described for LF, just the automorphic analog of ordinary motives. And so can you do this? Well, what you do is to use local and global. So remember how we put this together. It was in terms of extensions given by data C, and then extensions, and then fiber product over the vial group. Well, you're going to have possibly some extension of the vial group, and that would be fun to look for because you'd go through, you'd find out, you've got the extension already, T tilde of the Tanyama group. So there's going to have to be an underlying extension of the vial group, and that'll be kind of fun to look for. But in any case, use local and global analogs. GLV tilde and GL tilde of G 4G, let's say 4G tilde, given in I mean, these things that these guys define, Gan and Gao, from the work of Weissman, they look very similar actually to the extensions that we used, the global extensions that we used to define this group here. So I'm hoping that they would some thought that would allow one to maybe make a guess as to what this should be. Well, that's not the end of the story. Well, I'll just say try to guess, use local and global analogs given in GG in the same way. That's what I wanted to say, in the same way as GVL and GL. These things, it's in that paper that I wrote. It's also in it's in my 2001 paper in the Canadian Bulletin. It's also described in chapter, I think, 8 of the work of Langlands that I've posted. And anyway, we've described it in the same way. So I'll just say in the same way that GVL and G upper L here were used in the construction of LF. But that's not the end of the story by any means. Maybe that's the simpler part. One would then have, so I think that it should be possible to put that together, but then, we got to do some more, then what's the constructions in Fresson and Josen are quite elaborate. So, and in particular, they attach a whole lot of extra stuff to the motivic or the exponential motivic Galois group. So then try to find explicit evidence in LF tilde plus this group, putative group that one hopes that one can construct. So explicit evidence in here through. So this is this would be a locally compact group, but then we'd hope to be able to construct a mapping. So through expected. And in fact, what I'm about to say may determine what this mapping ought to be. This would be LF plus into GF plus. So this is the group that we want an explicit formula for, but it's also the group that is given in very abstract terms by Fresson and Josen through various Tanakian categories that they define. They describe this group, but not explicitly and not in terms of automorphic alpha, not in terms of automorphic forms. So I'll say of many, of the many supplementary new properties and I guess a lot of them are actually realizations in the technical sense used by Deligne and Fresson and Josen. This group is the heart of everything, but it's going to have many realizations described in Fresson and Josen. So this also is really interesting, and this, I mean, for me anyway, I'm going to work very hard on trying to understand what's in that book. And so, but what are some of these things? There's a period realization. Well, that exists. That exists also for ordinary motives, and it is implicit, I think, in the description of LF and GF ordinary motives. But the period realization, and that's actually a combination of the Betty and Durham realizations. But these are for exponential motives. These are not for ordinary motives. And they're discussed in considerable detail. That's uses techniques and ideas that I'm not all that familiar with. Excuse me. And then worse, well, better, I guess, if you like new stuff, perverse, in the sense of perverse sheaves. So this is a period realization, the Betty and Durham realizations, the period realization. The D-module realization. There's just a whole host of these things. The L-adic realization. He doesn't really say much. They don't say much about this at all. In fact, I think they haven't written it yet. The L-adic realization. Well, I'll just mention these things wrongly because I don't have no idea really quite what they are, but they're stuff that's associated with this group. It has to be associated with this group. So I will mention it. Nearby cycles. Monodromy. These are all discussed at great length in this paper. What are called exponential Hodge structures. And this apparently is a term that was introduced by Seubelman and by Kontsevich and Seubelman. These are the guys that, my understanding is, they're attempting to really apply ideas not unlike this to formulating Feynman path integrals, a big problem in physics for 50 years, making it rigorous. So they define the notion of exponential Hodge structures. And the thing is that they're not quite the same as Hodge structures that one is used to. And I'm almost finished. These are in the later chapters. This is in the later chapter of Fresson and Yosen. What else? Well, closely related to this would be the Hodge realization. And then I think basic to all of these things, so I would say most basic thing that one would need to, so I'm saying you're going to have to find these things. I mean, this sounds preposterous. You're going to have to try to write down a formula for the locally compact, exponentially, I would, maybe I shouldn't call it exponential, but the locally compact analog of the group L tilde F that would map into the exponential motivic, mixed motivic Galois group. So I'm saying, I hope, but perhaps one could write that down, maybe with a considerable thought, maybe a great deal of thought, but I hope that one could write it down. But then you're going to have to find inside that group that you hope to write down all of these things, because you've got to, you're going to have to find a mapping of that group into the exponential motivic Galois group, and these things should all be hidden in that group. I don't know, that's a pretty tall order. So, but I would say most basically, or most, I will say most importantly, but in the sense that it's got to be really, it's a basic to understanding all of these things. Most importantly, question mark, the relation, I think these are the same things, but it's a very superficial reading that I did. Most basically, the relation of the base A1 of these realizations. These seem to be realizations not in algebraic geometric sense. They are over basically affine one space. The base of these realizations well, I mean, there's something right at the very beginning that I think is the reason that all of these things in the later stages of F and J work with a base A1. It's because you are doing you're doing cohomology. You're doing Betty cohomology of rapid, what they call rapid decrease Betty cohomology. So the relations with the complex plane C used to define rapid, right at the very beginning, page 1 of their book, rapid, they call it rapid decay Betty homology. Everything in all of this has a parameter. It has a complex parameter Z. And what these lead to, and they're mentioned in various stages of the book, differential equations. So the things that are attached to this thing, but he has it as also writes it as A1, differential equations. So these would be differential equations with polynomial coefficients in one variable, complex variable. So differential equations on C with the regular singularities. That's kind of the basic underlying principle of what all of this is about, irregular singularities. And I guess they talk about, in their examples, irregular singularities, differential these things also lead to, are intertwined with, when you have a Galois group over, of something over the complex numbers, it's, I guess, called a differential Galois group. And Deligne mentions, for what it's worth, I haven't thought about this at all, but there's something else that's a huge theory that isn't even mentioned in this, and it's not mentioned in Fresson and Jossen, but it's the geometric Langlands program. The geometric Langlands program is the Langlands program not over a number field, but over the complex numbers. So, I mean, I just put this out for, I just put this out for what it's worth. It's mentioned on page 1 of the first letter of Deligne to Weissman, that it's something that he hopes for, but I don't know if it's quite what we're thinking of. But in any case, geometric Langlands, etc. And that's it. That's it. And I'm sorry to go over, but the point is, if this is the right track, we'd be guessing at a group LF tilde plus that's not terribly far from the group LF that we defined originally. Very simple way, a very concrete way. And I hope that there will be something. There's maybe more to it than that, but then it's got to contain hidden in it. It's got to contain all of these things. So it's a tall order. I hope it's true. And I think it is. I believe in it. I believe it's got to be true. Something, maybe LF tilde plus has to be larded with some other structure to allow for this. But I hope it'll, when it's eventually figured out, it's going to be more explicit. We hope. I believe it exists. Maybe you need to add more structure to it. Maybe Langlands parameters have to be from an extension of the Weil of the Weil group. But anyway, I believe and I hope that we'll be able to lard this group, we'll be able to equip this group with extra structure, but in a concrete, not unpleasant way, but that would have hidden in it all of these realizations. So that's what we would want to do. Okay, so hope you guys understand more of it than I do. Thank you. It's been a pleasure for me to give these lectures, to